Okay. All right. Welcome, everybody. Hello. Hello. I don't see you. I want to know if you are there or not. Like, the lights are looking at me, and I have, like, a black spot in the middle. All right. Usually I ask people, like, how many of you know Kotlin, but it's no use here because I don't see your hands anyway. So we are going to talk about Kotlin DSL and how to make DSLs with Kotlin. Try to make it under an hour. My name is Anton. I work for JetBrains. I work and live in Tallinn, a small city in Europe, in Northern Europe, in Estonia. And why we are talking about DSL today, I think it's not a really new topic. Though it's a quite interesting one. It appears over time, over years, again and again. Sometimes it's popular again to talk about DSLs, and then people try it and realize that they didn't work for their task, and they forget about it, and time passes, and they try it again, and they are disappointed again, and so the history repeats. I try to convince you that making DSLs with Kotlin is not that bad that it used to be with some other technologies. So if we talk about theory a little bit, when we speak about domain-specific things, it means that they are tailored for the specific task, right, that you have at hand. And making your own DSL, before making your own DSL, you should actually think what problem you're actually solving. We'll see what kind of problems are today could be solved with DSLs in Kotlin. But if you talk about theory, you probably know that there are external DSLs, the large group of external DSLs, and the internal DSLs. And by external, we mean the ones where we develop a grammar. So we describe a grammar, we implement the parser, we have to create a code generator. It's pretty complicated work, basically like a compiler engineering. And for this kind of things, there are tools. And one of the tools that JetBrains is making is MPS, Metaprogramming System, which is a full-fledged workbench that you get, like not just a parser generator or a code generator, you also get a tooling support. So you get an editor, you get all this autocompletes, and it has this very special editor that is called projectional one. But yeah, this is how it looks like. But we are talking about the internal DSLs today, where you don't really develop a grammar yourself, or you don't really create a parser. You are using the host language. In our case, it will be Kotlin, but it's possible also to do with other languages. And with this, you are basically limited by the host language itself, how much you can express and how natively you can express in that language. Probably it's not even fair to call them languages because you don't develop a grammar, you develop a vocabulary, right? So you develop it kind of a domain, you extract the domain that you're working with, and you develop a vocabulary, and then you kind of create your DSL, your internal DSL, which will be actually a valid host language, in our case Kotlin, but it will look like something different a little bit than just a program. So we are going to stay on the dark side today with Kotlin, because there are cookies, and I will give you a few examples of existing DSLs with Kotlin that are available as libraries today. And I want you to look at them and try to spot the similarities. So the first one is the Kotlin XHTML library, also developed by JetBrains, which is used to generate HTML documents. So if you don't even know Kotlin much, you can actually comprehend the example, right? What it creates. So obviously, it creates an HTML document, right? Looks very much like a method call and then some sort of a JSON document after that, right? Next one is an Anchor library. It's a library developed also by JetBrains for Android development, where you define the layout of your Android app. Even if you don't know Kotlin, you still can comprehend or like understand what it actually does, right? So it creates a layout where you have two fields, two text fields and a button. So a login, right? Another one, if you have used Kubernetes, you had to write YAML files, YAML configuration files, which are not statically typed. And some people are not really happy about that, so they create DSL in Kotlin so that it could be compilable and generate YAML using this one. Again, a nice example. Or TeamCity, the continuous integration server that is developed by JetBrains. It's also possible to configure your builds using Kotlin in there. So it has its own internal DSL for that. And another one, a small example, a Ktor web framework, where it has its own DSL, but now you see there like routing, and there you see a get method that handles the route request. But inside that you see the previous example where we generate the HTML file. So we kind of intermixing two different DSLs in one program, in one file. And that's due to the fact that it's actually a valid Kotlin program, and it's a valid Kotlin syntax, and we don't really have any problems intermixing those DSLs in one file. It can be one DSL, two DSLs, three DSLs. It's still one valid Kotlin program. So did you spot the differences or the similarities? You can shout out. Louder? Nested blocks, right. So this is exactly the answer I was looking for. They look very much similar in a way, of course, because they are developed with Kotlin, but one property that they share is that they consist of nested blocks. So let's see like the abstract example. So we have a nested block that starts with some sort of a verb or like a term, and then we have a block opening, and then there could be another block. There could be an assignment of an property or attribute. Then there could be another property that is being assigned by another block, and so on. And then there is like some sort of syntactic sugar that can be used. That's also like valid for Kotlin. And of course, we can invoke functions inside those blocks or create objects. And it's all valid Kotlin program, so it can be syntax highlighted, and all the nice things by IDs can also be applied, right? So it feels like magic. So let's do an example and type some code and see how we actually can transform an existing Java code into idiomatic code in Kotlin that will look like a DSL. I hope the font size is big enough for you and everybody can see it. So let's even do it like this. Nice. So we have a Java code which is not, there is nothing wrong with it, right? So it's a simple code. Everybody can read and understand what it does. There is a few classes involved in this example. So there is a client builder, company builder, Twitter builder. And we are going to transform this code into Kotlin by small steps. See the like small steps that lead us to creating the structure, those nested blocks, and how it will look like. So the first step that we do, we just copy this code and go to the Kotlin file that I have here that is currently empty, and copy it here, and the ID actually tells me that I can convert this Java code automatically. So it will do the first transformations for me. I will accept it. And if you're not familiar with Kotlin, I will just go over those small changes that it made during the transformation. First of all, on the left, you will see that there is no type definition. That's val, right? So in the new Java, we have a var keyword for the local variables, but in Kotlin, there's val, and there's Sorry, something is wrong with my focus. Okay. So there's val and var keyword, but there was a final keyword in front of the variable name in my Java example, so it transformed into val. Next, we don't really have, like, we could actually define our types here, right? But we don't really need that since we have type inference. Then we don't really have a new keyword, it's implicit, and we don't have semicolons, they are not needed. So that's the first example. The other transformation that we created here is that we don't really call the setter directly. The setter call looks like a field assignment, but instead it actually is calling is calling a setter directly. So it's like just a syntactic sugar that we get here. And another small thing that is different from Java is that we have string interpolation with this expression syntax inside the strings. So let's run this example and see what it produces. Compilation is not too fast. Sorry for that. Run. Okay, so it created some sort of an output. And the toString method is not implemented for the client class, and I cannot change the class. Assume that the class is not actually in my project here as a source, but I have pulled it in as a library. So imagine all the Java classes that I'm using are coming from the library, so I have no control over the source. So what could I do to actually pretty print this variable here? In Java, we would actually do something like this, like do concatenation, call client, and then call the Twitter, and then handle, and do this kind of concatenation. In Kotlin, the idiomatic way to, or if you wanted to create like a nice string, we would probably create something like a client util class and have a static method in there that takes in client as a parameter and produces this nice string for us, so that we would have like some kind of abstraction in front of this client code. But in Kotlin, the idiomatic way is to create an extension function on the client. So we are not actually changing the code of the client class in Java, but we are creating the extension in Kotlin code for the client class that is in Java, right? And it could be something like console string, and it produces a string, and the body of the method actually refers to client as the receiver. So whenever we type this inside the body, we actually are referring to the client. So this is the client inside this block. So we can actually get access directly to the fields and create some nice string like company name return. So this is like a very Java way to write this kind of extension. Actually, since it's just one-liner, we don't really need to do a return and to do a block and define a type. We can just replace it with the expression. So it looks very much like an expression, and we can try to see what's the result there. So let's run the application again. And we have a nice result, right? So instead of just class reference or object reference, we are actually printing out the actual values. The next thing that we can actually improve here with this code here is that we would call not the method, instead we would call or like refer some property And the same way as you add extension methods, in Kotlin you can add extension properties. Client to console string, which is a string, and we can create a getter, which will be the same as in the extension method. So again, now we don't really have to call the method in our client code. We are just referring to the property. Our unit test works. You see, the result is as expected. There are other things, nice transformations that you can do here with the code that we have just written. We are using the concatenation. Actually, we could use templates the same way as we do in our client code. And the same here. Template. All right. So the transformations that I've done right now, they don't really lead us to creating the nested blocks yet. But those are two small things that are fundamental to our next steps, that we can add something or like mix in something to the existing class, like extension methods, extension properties, right? So in my examples that I've been showing it to you in the slides, you have noticed that all the nested blocks starts with some entry point, which is a method, actually a method call that is called something like create element, create HTML, create client. It could be here, right? So if we define our entry point, it could be something like create client, or just a client, maybe. Why do we have to be two verbose here? That will be creating a client, and we have to pass in a block, right? That will be executed inside that method. This will be our entry point for building the client, and the entry point for our nesting, or for our nested blocks. And if we think in Java 8 terms, a block is actually a lambda, and lambda in Java is represented by what? A functional interface with one method, right? And in Java 8, there is a functional interface that takes in a parameter and returns nothing, which is called a consumer, which is a parameterized class. And we are going to use it to populate client via client builder. If you don't know about the consumer, we can check the Java doc. It represents an operation that accepts a single input of generic parameter and returns no result. So we are going to define a block as a consumer interface and pass into the function that we are currently defining. Okay. So since we need an argument for that function, we need to create the client builder. So while builder, client builder, and then we call the accept method on the consumer, passing in the builder, and return the result from the builder. So that the consumer interface will take in the builder, do something with it, call the methods on that builder, and then we are just using the result of that operation, right? So now we can start using the method, and instead of creating the builder in our main method, we are going to create client right here with client method. We don't really need this client anymore on the bottom. And we now have to create the anonymous implementation of that interface that is being used as a parameter, which is an object, client builder. Oh no, sorry, it's a consumer. Consumer, and parameterized as a client builder. And we need to implement the methods, which is just the only one. And actually, we already have all the required code on the bottom of the method here, we can just move in the block of code inside the method, and you already see that we are creating the nesting here, right? So there's like a client that accepts interface, and inside interface we have another method. So we kind of have a nesting there. But IDE is already telling us that we can improve a little bit. So we can convert the interface to lambda instead. Then we don't need the generic parameter grayed out. And now it's already nicer a little bit, but not really. We can, since lambdas are native to Kotlin, we can actually get rid of the functional interface here. How can we do that? We need a lambda that accepts a parameter and produces nothing. So we can go to our method definition here, remove the consumer interface. Actually, not remove it, but yeah, the interface we remove, and we define a functional type which accepts the builder and produces nothing, which is a unit in Kotlin. And now the only transformation we need to do, we need to call the functional type, so we don't really need to call the accept method. We can just call the functional type as a function by passing in the builder. So we now have a valid code. And the only thing we need to do here on top, we just need to get rid of the interface. It's already nice valid code, but IntelliJ is already telling me that you can improve, move lambda argument out of the parenthesis, meaning that if it's just a single parameter and it's a lambda, we don't really have to enclose it into normal braces. And we can have our first block that it's a goal for us, right? We are creating the nested blocks. We have a function call and a first block. Now, since it's just a one argument lambda that we have here in this block, we can actually rename it to it, which is an implicit name for a single parameter in the lambda, so we can get rid of it. And it's already cleaner. As you can see, the IDE, I hope you can see it, the IDE prints the hint that it is an implicit argument and it has a type of a client builder. So whenever I type it, it's actually a client builder. So it looks nice, but not too nice yet. The fact that I have to type it here actually is kind of limiting. We want to get rid of it. And for that, if I want to, type it like this, I need to be able to say that not it is a client builder, but this is a client builder. So the implicit receiver within that block, this should have a type of client builder. And if you remember, the implicit receiver in our extensions is this, right? The extension. The receiver where we create the extension gets the implicit name of this inside the block that we are defining for that extension. So it's an extension and it's a block. So we need an extension block, which is an extension lambda, which is actually a lambda with the receiver as an official name in Kotlin. And to create that, we can transform our functional type a little bit here by saying that the lambda that we define or we should receive in that method should be an extension lambda for the client builder class. Meaning that whatever happens in that block that we pass in happens in the context of the client builder. And as you can see, the it is now invalid syntax, so it's an error, but the first name is a valid one, right? Because it's now the implicit receiver is this, and it has a type of client builder. So we don't need to type this, and we can get rid of it, and now it's clean. So the very first part of this block looks as something like we wanted it to look like. Okay, but there we have two other blocks that we can transform in a similar manner. And how would I like it to look like? Something like this. Twitter, and say I want to define a handle within the block, and it should be a valid structure. Now, what should we do to make it a valid code? Twitter is a method call. It looks like a method call, like which accepts a block as an argument. So it's a very similar situation that we had in the beginning with the complete block of code. So we needed a method that would have an implicit receiver of client builder, meaning that we need to create an extension method for the client builder called Twitter that will accept a block. So let's do that. Fun client builder, Twitter, and it will produce, no, it will not produce anything. And now the type that we will define here should be the Twitter builder. So it should be happening in the Twitter builder context, meaning that we will have to define a block, Twitter builder, and an extension lambda for that type. So we now have to execute this block in the context of the Twitter builder. And for that so there was an assignment to the field, which is a field of client builder. So to execute that block, we cannot just execute it, right? So it has to happen in the context of the client Twitter builder, but here it would be executing in the context of client builder. So we need to do it a little bit differently. Instead, we should create the client builder instance, and to execute a block of code in the context of that existing object, we can use the apply method, and as a result, we can call a build method and assign it to our field of the client builder. Right? What's the apply method? So it's an inline function. In Kotlin, there are inline functions that basically don't exist at runtime, and inlined as blocks of code into your existing code. But it calls a specific function, which is a block, with this value as a receiver. So I'm calling it on an instance of the Twitter builder, and returns this as a value. So it will just execute that block of code, which is this block, right? So it will execute it, it will assign handle a value, and return Twitter builder itself, so we can call a build method on it, right? And as you can see, it already compiles. So we have fulfilled our requirement here as well, and the only thing that is left is transforming this other block, which is basically the same. We just need to use a little bit different types. Instead of calling it a Twitter, we should call it company, maybe, and use company builder, and use assign to a company field, and use company builder here as well. So then we can define something like this: a company block, move in those two fields, and do our magic transformation, and remove the other code. So now we have transformed our initial program. Here's what we started with. Let's see. So we started with the example that is easy to read, actually, and nothing is wrong with it. Let me see. But you definitely need to put a little bit more effort to parse and understand what it's actually doing. It's a small example, and as you can see, we don't really win on the number of lines. So it's how many? 21 lines, and here we have also 21, 25 lines, more spaces in between. But it's definitely less characters. So it's less effort to parse, and since it has a structure, it's easier for the eyes to actually understand what the code is doing. And you get the benefit when you're working not just with just imperative code, but when the code is actually creating some sort of a nested object structure or a configuration, which is hierarchical, where you need grouping of the properties and so on. So there it actually shines. Okay. The fact that we created a small internal DSL, so this is what makes it a DSL here, is not just beneficial on its own. You get benefits when you can reuse the code, right? Meaning that you would extract this kind of extension functions into a library and reuse it in different parts of the application or between the projects and so on. Otherwise, you have just introduced another layer of complexity in your code, and you are not actually making it simpler. So that's the benefit of creating this kind of structures, that you can reuse them as libraries. But when you create the libraries and you give it to the users, you should actually provide some meaningful ways or meaningful mechanisms to prevent mistakes of the users. For instance, if we look at the DSL we have created right now, it works nicely, but if we start moving blocks around, it still works nicely by accident. In fact, it's just the way it's implemented, right? But it's just a coincidence that the company method is currently executing still within the scope of the client builder. The Twitter builder could define its own company method, and there they would clash, and you might have a little bit different behavior, not the one you expect. So for this kind of things, there is a way to prevent intermixing those those blocks one within each other, by using a DSL marker annotation, annotation class. But you can not use it, since it's a meta annotation, you cannot use it directly. You should create your own annotation and use the DSL marker, and then this annotation is used to check the receivers of those blocks. So we have to mark our classes with this annotation that participate in this internal DSL. I cannot change my initial classes, since I made the constraint that they reside in the library, but we can extend those classes and mark them with this annotation. So I would create my own class client client builder DSL that extends client builder, and mark with this annotation. And then I need to do the same with the rest of the classes, like Twitter builder DSL, and it will be a Twitter builder, and also mark it with the annotation. And then the other one was company builder DSL, which is company builder, derives from company builder, and also marked as a client DSL class. And then, of course, here we need to use the other types instead. So so that the receivers would be checked against the new types. And the last block, the DSL as well. Okay, so now if I start moving the blocks one within another, the compiler will check the receiver and say, hey, they are intermixing, you are doing something wrong, please don't do that. But if I had, okay, it doesn't matter actually, but you see there is like some sort of a way to prevent intermixing the methods. It's not perfect. I think there should be a little bit more ways to gate this kind of things. There are contracts as an experimental feature. I hope we can use it in the future to actually check and put some validation rules on this kind of structures so that the users of the DSLs would be more confident in using your libraries that provide DSL extensions. Okay, so we were defining the new vocabulary, which is a client, a Twitter, a company. We were not defining any new grammar rules, and we are still using Kotlin. And we have defined all kind of nested blocks here. But the DSL possibilities are not limited to this kind of things. We can do some other things as well. Let's see the client class. That is a Java class actually, and the client class has a first name, last name, company, Twitter, but it also has a date of birth. So let's define a date of birth for this client. DOB, that's a local date, right? And what was it? Local date of, and then you have to define 2001. March, and let's say March 19th. So everything looks nice as nested blocks, but this expression doesn't really look too much DSL-ish, right? So it could be nicer a little bit. But this is the local date, and this is how the API works. We are using Java class here. Actually, there is a nice trick that we still can do with extension methods, and by adding the extension method to the integer, which is not really a good practice, but let's say we are doing it just for this example, just within the scope of our library, we can add an extension method which will be March, like a month name, and then define something like this, 19th of March, 2001. So we don't have to call the method using the dot. So whatever I typed here was actually calling a method on number 19, which is March, and passing in 2001 as an argument. Since the method is defined as extension method to an integer class, and it has only one parameter, we can mark it as an infix function. And then the infix function has this really cool property that you don't have to call it through the dot, and you don't have to enclose the single argument into the parentheses. So you can amend the dot and amend the braces and